Multiverse theory. Are there other universes? When we look at the night sky, we see countless stars and galaxies stretching out as far as the eye can see. It feels as though the universe we inhabit is infinite, a vast expanse filled with galaxies, planets, and cosmic wonders. But what if our universe is not the only one? What if there are other universes, each with its own laws of physics, stars, and perhaps even forms of life? This idea is at the heart of the multiverse theory, one of the most intriguing and mind-bending concepts in modern science. The multiverse theory suggests that our universe, the one we can observe and measure, may be just one of many universes that exist simultaneously. These universes together form a multiverse, a collection of realities that may be similar to ours or completely different. Unlike science fiction stories that imagine parallel worlds, the multiverse theory arises from real scientific ideas and observations, although it remains highly speculative and difficult to prove directly. One reason scientists consider the possibility of a multiverse comes from cosmology, the study of the origin and evolution of the universe. According to the Big Bang Theory, the universe began as a tiny, hot, dense point about 13.8 billion years ago. From that moment, it has been expanding and cooling, forming galaxies, stars, and planets. However, some models of cosmic inflation, which describes a rapid expansion of space immediately after the Big Bang, suggest that this expansion might not have been uniform everywhere. In some regions, inflation could have continued for longer than in others, creating separate bubbles of space that develop into independent universes. Each bubble would be a universe in its own right, potentially with different physical laws and constants. Another reason for considering the multiverse comes from quantum mechanics, the branch of physics that studies the behavior of very small particles. In quantum mechanics, particles do not have definite states until they are observed. Instead, they exist in a superposition of possibilities, each with a certain probability. Some interpretations of quantum mechanics, particularly the many worlds interpretation, propose that every possible outcome of a quantum event actually occurs, but in a separate, branching universe. According to this view, there could be countless universes in which every possible outcome of every event has happened, forming an almost infinite web of realities. The multiverse theory also emerges from the study of the fundamental constants of nature. Our universe appears to be finely tuned for the existence of life. If certain constants, such as the strength of gravity or the charge of the electron, were slightly different, stars and planets might not form, and life as we know it would be impossible. One way to explain this fine-tuning is to suggest that there are many universes, each with different constants. In this scenario, it is not surprising that we find ourselves in a universe capable of supporting life, because only in such a universe could observers like us exist. This is sometimes called the anthropic principle. Despite these theoretical motivations, the multiverse remains a controversial idea. One major challenge is that other universes, if they exist, may be completely inaccessible to us. Light and other signals cannot travel between universes, so direct observation might be impossible. Without the ability to observe them, some scientists argue that the multiverse is not truly a scientific concept, since it cannot be tested or falsified in the traditional sense. Others, however, suggest that indirect evidence, such as patterns in the cosmic microwave background radiation or unexpected anomalies in fundamental physics, could hint at the existence of other universes. Different versions of the multiverse theory propose different ways that universes might exist. In some models, universes are separate regions of space that never interact. In others, universes could exist as parallel layers or dimensions that overlap with ours, but in ways that are imperceptible to human senses. Some theories even propose that entire universes could pop into existence and disappear again, creating a constantly changing landscape of realities. The idea of multiple universes raises fascinating philosophical questions as well. If there are countless universes where every possible outcome occurs, what does that mean for our understanding of free will, identity, and reality itself? Could there be another version of ourselves making different choices in a parallel universe? These questions are not only scientific but also deeply thought-provoking, challenging our sense of uniqueness and place in the cosmos. Despite the uncertainties, the multiverse theory encourages scientists to think beyond the limits of what is currently observable. It pushes the boundaries of physics, cosmology, and philosophy, offering new ways to address some of the most fundamental questions about existence. While direct proof may be out of reach, the theory provides a framework for exploring the possibility that our universe is just one among many, a tiny bubble in an unimaginably vast and complex multiverse. The pursuit of understanding the multiverse also drives technological and observational advances. Astronomers use powerful telescopes to study the cosmic microwave background, the faint radiation left over from the Big Bang, in search of subtle irregularities that might indicate collisions with other universes. Particle physicists probe the behavior of subatomic particles at extremely high energies to test theories that could imply the existence of multiple universes. Each experiment, each observation, brings us a little closer to understanding whether our universe is unique or part of a much larger cosmic ensemble. In the end, the multiverse theory reminds us that the universe, or perhaps the multiverse, is far stranger and more complex than we can imagine. What we see with our eyes is only a tiny fraction of reality, and the vast unseen possibilities challenge our imagination and expand the horizons of science. Even if we never directly observe another universe, the very concept encourages curiosity, wonder, and the search for answers to questions that have fascinated humans for centuries. As our knowledge grows, we may one day gain new insights into the multiverse, discovering whether other universes exist and how they relate to our own. Until then, the idea remains one of the most exciting and mind-expanding possibilities in science, reminding us that the cosmos may be far more vast, mysterious, and beautiful than we have ever imagined. If you found this explanation intriguing and want to explore more fascinating ideas about the universe in simple and engaging language, do not forget to like this video and subscribe to the channel for more amazing content.